Hello everyone, welcome back to the solutions for the past year questions of the AP Calculus AB exam. These are the free response questions from 2024 and we are at question 5. Okay, so question 5 gives you a curve and its derivative. So that portion is already done for you. And there are 3 subparts that are related to the curve that is given in the question. The fourth subpart is related to the concepts that are developed in the first 3 subparts, but it uses a different curve. Okay, so we will handle question 4 as we get to it. But for the first 3 parts, we need to concern ourselves only with the curve that is given in the question. Okay, and that is x square plus 3y plus 2y square equal to 48. The derivative is also done. Let us look into the first question. The first question says, subpart A, there is a point on the curve near 2 comma 4 with x coordinate 3. Okay, of course, if the x coordinate of the given point is 2 comma 4, the point with x coordinate 3 will lie on it. Use the tangent at the curve to approximate the y coordinate of the point. Okay, so it's not explicitly stated whether this unknown point lies on the tangent or not, but it is said that we have to assume that whatever point is given will lie on the line y equals to will lie on the line x equal to 3. Okay, and we have to figure out its y coordinate. All right, so it will look something like this. If I can give you a rough sketch. So basically this might be a portion of the curve. This might be 2 comma 4 and you have another point at 3. This is 3 comma y, and it is said that you approximate the tangent here, and based on this x equal to 3 line you find the intersection to understand the y coordinate of the point. Okay, it's a very rough diagram, but I'm just approximating what has to be calculated. All right, so they are asking for the approximation because it may or may not be a straight line. Okay, that is never stated, but well, if they want an approximation, we will just calculate just that. Okay, so for this we need the slope of the tangent and the equation to the tangent, right? Equation of the straight line approximation of the tangent. Now the tangent is calculated as the value of the derivative at the given point, right? The derivative is already given, so using that we can calculate the derivative at 2 comma 4, right? So this will give us minus 2 into 2. Just replace the values of x and y in the derivative that is given. So 3 plus 4 into 4. 4 for 16 and 3 19 minus 4 by 19. Alright. So for this unknown point 3 comma y, what will be the equation of the tangent? Okay, before we put the value of the tangent, let us write down the equation of the tangent. So equation of tangent, we will be using the 1 point formula for calculation of the equation of straight line, which is y minus y1 equal to m into x minus x1. This formula, y1 and x1 are the known coordinates of a particular point and m is the slope. So my equation turns out to be y minus, one of the points is known, right? 2 comma 4 is known, so y minus 4 is equal to m is minus 4 by 19 into x minus x1 is 2. So this turns out to be, yeah, fine, this turns out to be y is 4 minus 4 by 19 into x minus 2. Now from here we can approximate y, right? You can just write, put x equal to 3 to approximate y, and this will give us y equal to 4 minus 4 by 19 into 3 minus 2, which is just 4 minus 4 by 19. Now 4 19 is 76, 76 minus 4 is 72, so y will be 72 by 19. Alright, this is an approximation in case the line joining 2 comma 4 and 3 comma y would be a straight line. Okay, assuming that it's a straight line, this is an approximation for y. Now the equation for the tangent was not necessary to be calculated, but without calculating the equation of the tangent, if you could put the value of x directly, that would have also fetched you the full marks. Okay, so the portion that I've written in black, if you did only that portion, you would have gotten the full marks. But then again, the solutions that are presented on the official website are given to direct the examiners on how to evaluate the scripts rather than as a direction for the students on how to solve them. All right, so it would make sense if you know the solution and then you read the official solutions. But if you have no knowledge of how the question is actually solved, the bare bones solution that is given in the official answer will not make much sense to you. Because if I say equation of the tangent and then write the portion in black, you would have some difficulty in filling the blanks if you are preparing for the exam. Okay, so this is one of the main reasons why we are creating these videos for you all right. Okay, so sub part A is done. We have an approximation to y. 72/19 is accepted as the official answer. All right, is the horizontal line y equal to 1 tangent to the curve? Give a reason for your answer. Fine, let us check. Horizontal line y equals to 1. Okay, so for this, let us first check what happens at the tangent, right? Now, if a line is a tangent to the curve, then the derivative at that point will be 0, right? Because it would be a tangent only if it is parallel to the x-axis, right? So if we, well, no, that is not the case. It will be, for it to be a tangent, we would just check if the first derivative is equal to 0, right? First derivative equal to 0 means it's guaranteed to be a tangent that is parallel to the x-axis. That condition is not required here. All right, we just need to know when it is guaranteed to be a tangent. It will be a guaranteed tangent at first derivative equal to 0. All right, whether that tangent will be parallel to the x-axis or at a particular angle to the x-axis, that is of no concern to us. To guarantee a tangent, we would take the first derivative to be 0. All right, so we take derivative equal to 0, which would mean this equation that is given, minus 2x by 3 plus 4y. This is equal to 0, which means x equal to 0, right? So x equal to 0 and the horizontal line that was given is y equals to 1. So what would be the point of tangency? This is 0, 1, right? Now for a horizontal, I hope you understood the reason why we did the first derivative, why we set the first derivative to be 0. Because to guarantee that a horizontal line will be tangential to the curve is saying that it would be a tangent at the inflection point or the critical point, the turning points, etc. Okay, because only at the maxima or the minima will the horizontal tangent appear, because horizontal means tan 0 is 0, so slope is 0, then slope 0 means it's parallel to the x-axis, that means the horizontal line. So the point of tangency should be 0, 1. All right, I hope it's clear, because it's the line y equal to 1 and x is 0. All right, so we would have to check if this point actually lies on the curve. That would give us our entire solution. So check. Now the curve given is x square plus 3y plus 2y square. It does not look like it will lie, right? So x square is 0 square plus 3y, which is 3 into 1 plus 2y square, right? So 2 into 1 square. This is not equals to 48. Therefore, we can conclude y equal to 1 is not a horizontal tangent. Alright, I hope it's clear. Part C. The curve intersects the positive x-axis at the point root 48, 0. Is the line tangent to the curve at this point vertical? Alright, so for a vertical tangent, we should have the first derivative as non-existent, right? So we would have to check root 48, 0. Alright, let us check if root 48 comma 0 is existing on the slope. So derivative was given to be minus 2x by 3 plus 4y. Now check at root 48 comma 0. So this turns out to be minus 2 root 48, 3 plus 4 into 0. This exists, right? This is some constant c which belongs to real numbers, isn't it? Now since the value exists here, that means it cannot be a vertical tangent, right? A line is a vertical tangent or an asymptote only if the derivative at that particular point does not exist. Here it exists. So the denominator is non-zero. So you can use this line of reasoning. They have accepted this line as the official answer. You can say that the denominator of derivative is non-zero. Therefore, the line tangent to the curve is not vertical. Okay, as denominator to dy dx at root 48 comma 0 is non-zero. Therefore, vertical tangent does not exist at that point. That's enough. Okay, so this was accepted as the official answer and we'll leave it there. You just had to check if the line tangent to the curve at this point is vertical, and the reason was also stated in one line because the denominator of the derivative was non-zero. Okay, if it is 0 then you would have accepted the answer as yes, but since it is non-zero, it's no. Alright, subpart D. Subpart D is actually relating to the concepts that have been developed in the first few subparts but uses an entirely different curve. It says for time t greater than 0, a particle is moving along another curve defined by some equation is given. At the instant the particle is at 4, 2, the y coordinate of the particle's position is decreasing at the rate of 2 units per second. So the rate of change of any variable is its derivative, right? That means dy dt is given. The rate of change of y with respect to time, that is dy dt, is given to be minus 2. Okay, at that instant what is the rate of change of the x coordinate? So we have to find dx dt. Alright, so this is an exercise on implicit derivatives. So we have to first note down the curve. The curve says y cube plus 2xy equal to 24. Y cube plus 2xy equal to 24. Right? Have I copied it correctly? Yes, I have. Which means y cube plus 2xy minus 24 equals to 0. Now we differentiate it with respect to t. Okay, because we are checking the position of the particle with respect to time, so we differentiate with respect to time. So this will give us 3y square dy dt plus 2x dy dt plus 2y dx dt, and the derivative of the constant will be 0, which is equal. Alright, now what are we given? Given the coordinate is given to be 4, 2, right? So x equal to 4, y equal to 2, dy dt is given to be minus 2. We have to find dx dt. That is the question, right? Substitute the values, you should get your answer. 3y square. So 3 into y square. Okay, here we could have taken 2 common, right? That makes more sense. Alright, so 3y square, 4, 12. 12 into minus 2 plus 2 into x. X is 4 into minus 2 plus y is 2 into dx dt, supposed to be 0, right? Which means 24, 12, right? So minus 24 goes to that side, becomes plus 24, divided by 2, it becomes 12. So this is minus 8 plus 2 dx dt equal to 12. So this becomes 20, implies dx dt is 10. Okay, that's the answer. So as you see, this was nothing but an exercise in implicit derivatives, and well, we didn't use any of the concepts from the first three. I thought some of the concepts will be essential, but hey, the only concept that has been repeated here is the concept of derivatives. So if you are comfortable with derivatives, you should be able to do the fourth part of this without any issues. Okay, just make sure that you are treating 2xy as both x and y being functions of t. Okay, do not miss out on the x dy dt as well as the y dx dt part, because everything is implicitly related with respect to t. So when you are differentiating with respect to t, we do not treat x and y as constants. This is not partial derivatives where other variables are treated as constants. You will learn about that in higher calculus. All right, so again, this question had 4 parts. The fourth part was a bit unrelated, but the first 3 parts were quite easy. They were just the basics of tangent and normal. We dealt with the tangent only, we did not have to calculate the normal. We just had to deal with the approximation of tangent in the first part. The second part had just a check on whether it will be a horizontal tangent, and we know that horizontal tangent exists only at the extremum points or the inflection points, the critical points, etc. So we set the first derivative to be 0, calculate the value of x, got our point, checked if the point is on the curve. It was not, so it was not a tangent. The third part had us check the vertical tangent. Now a vertical tangent or an asymptote is possible only if the denominator of the derivative is 0 or if the derivative does not exist there, right? Because the derivative was existing, we could find a value to it. Never mind what value, there was a real value associated with the derivative, therefore it was not a vertical tangent. And the fourth one was an exercise in implicit derivatives, a very easy one at that. You just had to put the values accordingly to get the solution. Okay, so again, a very easy set of questions. If you need any help relating to this chapter, of course AP calculus only has a few chapters of calculus, but then again, any revision, any concept clearing help if you need, do not hesitate to drop a WhatsApp to the number that is given below my face panel. And if you do have any other suggestions, comments, feedback of this video, do use the YouTube comment section. Okay, our contact details will also be mentioned in the description box of this video, so you can contact us via that also. All right, so I thought this was the last question for this exam set, but it appears there is one more question. So let us solve the last question and I'll see you then. All right, bye.